The technique of solving a shapeshifter cuboid is to turn it into a domino. By turning it into a domino, you don't do any more shapeshifting, and you solve these doing 180-degree turns. So how then do we solve these last two layers here? Well, it starts off simple again. Pick any layer. It's going to be the easiest part of the solve. Now, none of these may or may not be reduced, but since these are in, I'm going to start off with this layer over here. It's all sliding U technique. It's no worries. I want to put a blue one here. Find a blue one from the bottom. Here's a blue corner piece over here. So this is going to come into here by doing a 2R at the end. So I'm moving the end 2R. Move it to the L position, then do a 2L. Swing it once again to the R position, and you're getting these back. Move the 2R back, swing it to the L position, move it back over here. The joy of this is it won't disrupt anything that you did, and you put that right in here. To put this guy here, find the blue on the bottom, which is right over here, and now we're going to swing it in from the middle. So this is a 2L from the middle, then swing it to the right. Now we're going to move it to the end right, to R from the end, swing it back to the middle, and this will help guide us where we're supposed to go, to L from the middle, back to the right, to R, and swing it back. So now this is in. Now we have to find the white, put a white one in position. We've got this over here, swing it, to R from the middle, swing it to the left, to L from the end, back to the right, 2R from the middle, back to the left, 2L from the end. So now this is in, and we just do it step by step like that. Find a white one, right here, swing it from the end, 2R, swing it to the middle, to the end with 2L. And you can keep track of where it's supposed to be just by visualizing it. So this is in. Now I find the white one, which is here, 2R, or rather 2L, move it in. So this is all sliding U technique. A fun, simple, quick way of getting this in. Now I find the green one. So remember, if you have it from the middle, you go from the middle to the end. 2R from the middle, move it to the left, 2L from the end, back to the R, and splat. Okay, need a green one, no problem, right here. 2R from the end, move it to the L. 2L from the end, move it to the R. Turn, turn, and turn. So again, I'm trying to find the simplest way of doing this. Find the green one at the end, see if we can find one down here. We've got it here. Move it from the middle, at the left, to the end to the right, back to the middle to the left. Whoop, don't lose track, like I almost did, and curse splat. Okay, we have a green one to put in. Green? No, yellow. This comes in from the middle, move it to the end. Turn it from the end, move it to the middle. So as you can see, there's a lot of repeats in terms of the technique of how we're doing this. One more, and that's a yellow. Right over here. Turn, move it in, turn, move it in. Now those that are having trouble with this puzzle, you're probably thinking, yeah, I got all this, I know all this, but it's that last layer. So here we are at the last layer, and this is where things may get a little bit tricky. The last layer is the middle layer here. First thing that we have to do is we need to reduce these guys. So now we're going to look at these as though they were corners. Now they're actually considered, if you were to look at it like this guy, they're considered to be edges over here, and they need to be placed. They need to be reduced, so to speak. It just turns out that they're different colors. Or you can look at them as centers, who knows. I look at them as specialized edges, and I'm going to move them as such. where this is the right side, this is the left side. So too, this is the right side, this is the left side. The way that we're going to do this is by edge swapping. Now, are there any two that are already in? Because notice when I put edges in, I look for two that are in and move it to the left. I'm looking around and I don't really see any here that are in. So I'm going to line up the same color here. I see this blue right next to that should be a yellow. So what I need to do is I need to put a yellow one in to here. Now the yellow one that needs to come into here is over here. So what I'm going to do is I'm going to flip-flop these two. I'm keeping my perspective. I'm going to hold it here and flip-flop these two to take this yellow, bring it here, so then I can swap it to here. So that's going to be 2R, U, 2R, U, 2R, 2U, 2R, 2U, 2R, U, 2R, UI, 2R. Now, don't be put off by this. You're going to create misplacement in this, and this layer. Ignore that for now. But I want to keep this to my right. So what I'm going to do, knowing that this blue has to be next to a yellow, I'm going to take this and flip-flop that into here. But let's move this to the side so that when I do a corner swap, this will swap to here. So I'm going to move this like here from the center because I'm going to look at these pieces as corners. Let's go ahead and do our corner swap. 2R. And again, we're just moving this layer here, U, 2R, UI, 2R, UI, D, 2R, UI, 2R, U, 2R, and this moves back. So I actually have this reduced now. I can even move this back, and you can see this is where it needs to be. What I'm going to do now, so that I don't lose sight of everything, is I'm going to have to, I'd like to take this misplacement out, which means I have to do some kind of an edge swap. In this case, what I'm going to do is I'm going to do an opposite edge swap. It's just easier to do. So I'm going to move from here, treating these as edges, 2R, 2U, 2R, and I'm just moving the middle here, 2U, 2R, 2U. Alright, so these are back in, and as you can see, this is now in as well. This is in. Now when you have two that are in here, corners that are in, hold that to the right, and you do another corner swap and it should get them all in. Well, this is a green, and just to the right of green should be a white. So do I have a white one here? I do. So if I swap this, do a swap over here, then this will be in and everything should be fine. If this functions as a domino. As a domino, when you do that, everything should be in if there's no parity to it. Now, here's the problem though. There should only be one corner pair that's in to make the edge. What you see is this is also in. So we have two corners that are reduced, both of these. Which means that even if I were to solve this, even if I were to go ahead and do that corner swap, it's still not going to work because these two will swap and then these two will swap. So this will be in and this will be in, but the rest won't be. This won't be in, this one won't be in, and this one won't be in. So here's what I mean. Let's say we didn't know that. We see these are in, we simply hold this to the side, we do another corner swap, and in every other domino cuboid, that should work. So that's 2R, U, 2R, UI, 2R, UI, D, 2R, UI, 2R, U, 2R, and this moves back. So you can see this is in, and you can also see this is in. So if this were like a domino, if you've got one that was in, you did the corner swap, and this is in, all the rest should be in. As you can see, this is not. This is not correct, and this is not correct. So how could this be? Basically, it appears to be something of a parity. We treated this as a domino, and yet it's not functioning as a domino. So could there have been a parity of reduction? We reduced a shape-shifting cuboid into a domino cuboid and find that we can't do the proper moves. This would be impossible to solve as a cuboid. And the answer is this is not a parity. This is another problem of false equivocation, because when you do a shapeshifter, unlike an ultimate shapeshifter, there is no parity of reduction. This should have worked, but it didn't. Because I know that there's no parity, I know it must be false equivocation. Therefore, there must be pieces in here that can be substituted for each other. There is rotational equivalency that we saw with these guys as we were rotating it to get these edges in. There's also something called translational equivalency, where one piece can be substituted for another piece, translated from one part of the puzzle to the next. So when I see this, when you see something like this in this layer, and you can't get more than 2 in, that means there's 2 colors that can be substituted for another. So when I see that, I'm simply going to take one of these edge pieces and substitute it for one of these. It doesn't matter which one. We actually have 4 to choose from. This, and this are all completely equivalent to each other. They display translational equivalency. So when you're doing the cuboid solve, if you're lucky, when I did my corner swap, when one was in, and then I swapped the other one to get it in, all the rest should be in. If not, simply substitute one color for another. So once again, turn this upside down here, and I'm going to take this yellow, it could be any yellow actually, or any color, and substitute it for this yellow. So again, sliding U technique. Actually, it's going to have to be this one. So this to come to here. So 2L from the center, move it to the right. 2R from the edge, move it to the left. 2L, back to the right. 2R, and back here. And the good thing about that is you won't disrupt that at all. And now this has been reconfigured. And as you can see, this is in, but none of the rest will be in. This over here is in. This over here is in. And this over here is in. So either one is in and none of them are in, or all of them are in. Now what could have happened when I substituted it is only one would have been in, and then I just do the corner swap once in the correct way, and then the rest will be in. So let's say I had to do a corner swap, but the one that belonged here wasn't here, it was here. I'll just do that adjacent edge swap, do the corner swap, and then swap it back to take the misplacement out. So that's how you do that. Now these have been reduced just fine. I can now look at these as edges, they've been reduced, and the final set of steps is now to put these corners in. First I'm going to look to see which corners where I have 2 that are properly placed, just like I did with this. Well, this is in here, nothing yet. This is in, and this is in, not and not. So keeping my perspective about me, I'm simply going to flip-flop these 2. 2R, U, 2R, UI, 2R, UI, D, 2R, UI, 2R, U, 2R, and this is back. So this is in, this is in, this is in, and this is in. Now all I have to do are edge swaps to get these guys in. Bear in mind the misplacement that happens, don't get confused with that. So what goes where? Well, let's see. This can come over to here. So why don't we do an adjacent edge swap over here? So holding one in front of me, one to the right, 2R, U, 2R, U, 2R, 2U, 2R, 2U, 2R, U, 2R, UI, 2R. This is perfectly fine here. Don't let this fool you, just focus on this part over here. But I'm going to keep this misplacement to my right. What belongs here is going to be the other blue. Where is the other blue? It's right here, it's across from here. So let's move this in position over here. Do an opposite edge swap to get this blue over to here so it can be next to this guy here. That'll be 2R, 2U, 2R, 2U, 2R, 2U. We got the misplacement out. And now we can move this back in. So you can see this is in and this is in. Well, now we have another bit of a problem. We're going to have an issue because we want to swap these 2 back, but we're going to end up with misplacement. Now, it would appear that if this did not have any parity, that this shouldn't happen. What should happen is that I would have 2 that needed to be swapped. So I should have 2 more. In other words, maybe swap these two, which will make the misplacement, and then these two, which will take the misplacement out. If you run into this situation where you end up with two that are out, we have to look at this, and again, I would say this is not parity. It's not parity because we didn't do any kind of reduction that would cause parity. This is another situation of false equivocation. But what's been falsely equivocated? These pieces are all fine. We don't have to touch those. But if we're going to flip-flop these two other pieces must also be flip-flopped that are equivalent to each other. In this case, it's going to be these guys. So when you end up with a situation where it's not in, when you're doing edge swaps, you have a odd number of edge swaps instead of even number of edge swaps, so you end up with this configuration. Take any one of these colors, I'll take a green, and trade it for one of these, doing a sliding U technique. So once again, hold this over here. So I'm doing this a little different than I did up here. I can't do that same URF algorithm by doing it on the opposites. Trust me, it's just not going to work because it'll disrupt these guys. So I'm going to take this, move it to the side, well, line it up correctly. I guess we'll be over here. So I'm going to take this and put it in this slot over here. It's going to be 2R, see it over here. Move it to the L position, 2L, move it back to the R position, 2R, move it to the L position, 2L, and be relieved that that does not change this at all. Now it's been reconfigured. We take another look at this, and we kind of start again. We find two that are in, doing the same thing in. These two have to be swapped, so I'll go ahead and swap them. Remember which are edges and which are corners. These are not corners and these are not edges. These are corners and these are edges. So just bear that in mind. So we're going to swap these two. 2R UU, 2R UI, 2R UI D, 2R UI, 2R U, 2R, this is swapped back. So in. We like this because only this guy is in, but none of the rest are, which means we have an even number of swaps, so we're going to be okay. Take this green, swap it to here with an opposite edge swap, 2R, 2U, 2R, 2U, 2R, 2U. So this is in. We have misplacement, but now we just swap these two, and then the misplacement will be back. So we've got the configuration correct. 2R, U, 2R, U, 2R, 2U, 2R, 2U, 2R, U, 2R, UI, 2R, and it's done. And at the end of the journey of both of these two, we discussed what parity is, or parity problems are. We discussed the difference between that and false equivocation. We discussed how we can recognize which one is which and how that changes the strategy of the solve. This one is kind of a doozy. We actually were lucky enough to find every kind of parity and false equivocation that there is. The complicated aspect of it was with this last layer, where we had two different kinds of false equivocation. False equivocation of one of these with one of these, which caused an apparent impossibility to get these reduced. And then a false equivocation of one of these and one of these, which caused an apparent impossibility to reduce, to do the proper number of swaps with these. Very challenging, fun puzzle. Hopefully this clarified some of the confusion with this. If there's any other questions on this or configurations I didn't go over, let me know. Pictures always help. Thanks for watching.